Hello everyone, welcome back to Grade Up. My name is Deepti Mittal. So guys, in these video lectures, we are studying computer organization. Till now, we have completed almost 96 to 97% of syllabus in our CO. This is the last topic which we are going to study in this particular subject, which is floating point arithmetic. And also, I am going to discuss the important topics or the topics which are important in your computer organization so that you can prioritize these topics while preparing for CO. So let us start with floating point arithmetic. Guys, I always follow the rule and I always say the same thing that before starting a new topic or before studying a new topic, you should know the reason why we are studying it. If you are clear with the reason, you are going to be clear with the concept of that particular topic. See why we are using this floating point representation. For representing our integer data or data of normal size, we used fixed point arithmetic or fixed point representation, where your signed integer takes signed integers will be represented. Suppose you are using n-bit place for representing some data, then your unsigned integers will be represented 0 to 2 raised to the power n minus 1. N minus 1. This is over here. That is, if you are going to represent your unsigned integer using n bits, the range of integers which can be stored in these n bits is 0 to 2 raised to power n minus 1. When you are going to store signed integers, then it will be minus 2 raised to power n minus 1 to 2 raised to power n minus 1 minus 1. This is the representation or range for your fixed point arithmetic. Now question came, why we are using these floating point arithmetic and what is the difference? See, we are going to use these floating point formats or arithmetic for representing very large or very small data. Suppose you are having some data like this. See the size of this data. For representing this much data, you need a larger size register. And suppose you have to represent this much small data. Definitely, I have taken this example. If data is also less from this data, then definitely you will need more number of bits for representing this data. You cannot do it with 32-bit or 64-bit. So this is the problem which we are facing. For representing such type of data, we use floating point format. We can represent such a huge data by using only 32 bits or 64 bits if you are going to use floating point arithmetic. Let us see what is the way of representing your data in floating point arithmetic. See, this is the general format for representing your data using floating point arithmetic, which is plus minus m into b plus minus e. This plus minus represents the sign of your data. This m is mantissa and this b is base of your data. For decimal number system, what is the base? 10. For binary number system, the base is 2. And this e is the exponent. See, this data can be represented as 5.678 into 10 raised to the power some bits, and this also can be represented as 1.2345 into 10 raised to the power minus some power. So I am going to represent my data in this format. But see, we are dealing with computer system, and in computer system, number is represented using binary format. Then this base becomes 2 over here, and this mantissa is going to contain 0, 1, 0, 1 and so on. So this base becomes 2 over here. And if I want to store my data in this format, the things which we have to store is this sign of data, mantissa information, this base information, this exponent information and the sign of this exponent. That is, you have to store these 5 information for storing your data using floating point format. But in computer system, base need not to be stored because it is implicitly defined or implicitly known that base of your data is going to be 2. So now you are left with 4 things which has to be stored. But for representing of this data, you will say you are going to represent it using a floating point format and data is represented using binary. So one will say I will store my data in this format 1.000 and so on. Okay, into 2 raised to the power something. One will say I will store it 0.111 and so on. So see, what are the information which you have to save? This sign bit information, this 1 or 0, what is the value which is present before decimal, second thing. Third thing, this mantissa. Fourth thing, this base exponent information and the sign of your exponent. Again, we are having 5 things which we have to store, but we are going to represent our data in the normalized form so that we can reduce some things which has to be stored. What normalized form says, you have to store your data in this form. Plus minus valid digit dot fraction into base with exponent. What this valid digit in your binary number system? It is 1. That is, whatever data you want to store will be stored as plus minus 1 dot fraction into base with exponent. So now tell me the things which you have to store. This signature, this sign bit, and this one need not to be stored because every time for every representation it is going to be 1. And see now, this fraction bit, then 1, 2 things, and this exponent information I have to store. So you will say you have to store the sign of this exponent, but this exponent is stored in such a way you need not to store the sign information. Let us see how we are storing the data. See, sign field will be used. We are going to represent our floating point data with 3 fields of information. First field is sign field. Sign field is used for representing the sign of data. If your data is positive, represent your sign as 0. If negative, represent your sign bit as 1. Exponent will be stored in the form of biased exponent. See, for storing your exponent, see over here, you need to store 2 things, this e value and this plus minus sign. So we were needing 2 fields, but this biased exponent will represent these 2 things by only a single field. Let us see how you are going to represent it. Biased exponent will be calculated as actual exponent plus bias. Your e is the actual exponent and whatever may be the sign, leave it, just add bias to it. Bias is a constant value which is equals to 2 raised to the power n minus 1 minus 1, where n is the number of bits used for biased exponent. Don't you worry about this thing, I will tell you how to calculate it. Then mantissa is used for storing the mantissa field, which is fractional part of your data. Okay, let us see the representation used for storing these 3 fields. Basically, in floating point arithmetic, we are provided with 2 standard formats for representing your data. One is 32-bit format and second is 64-bit format. In both the formats, you will use 1 bit for your sign data, but for biased exponent, in 32-bit you are going to use 8 bits and in mantissa you are going to use 23 bits in your 32-bit. For 64-bit format, 11-bit and 52-bit respectively. So you can clearly see this 32-bit format will be used for representing a smaller size data and it will be used for larger size data. Data where you want very much accuracy or accuracy is very important. Then you can use IEEE 64-bit format. So let us solve an example for storing your data using IEEE 32-bit format. Then you will get the clarity how to store your data using floating point arithmetics. Let us see. See, this x is equals to 0.125. This is the data which you want to store in your system. See this 0.125. First of all, whatever data you want to represent, you have to convert it into the binary format. So binary representation of this data is 0.001. Now for storing it, you have to convert it into the normalized form. What was the normalized form? Plus minus valid digit dot fractional part into your biased concept. So you should have 1 before this decimal. So how I'm going to represent it? 1.000 into 2 raised to the power minus 3. Okay? Because you can clearly see, to make this 1 over here, I have to multiply by 3 shifts has to be made. This will be 2 raised to power minus 3. You know, in your decimal, if you have something like this, then it is represented as 10 raised to power minus 3. It is quite similar in your binary number system. Now your valid digit is 1. First thing which you have to store your sign bit. Your sign bit over here is 0 because data is positive. Second field was biased exponent. Let us see how to calculate biased exponent. Biased exponent was calculated as actual exponent plus bias. Here actual exponent is minus 3 and the value of bias will be 2 raised to power n minus 1 minus 1, which is 127, because for 32-bit format your biased exponent field have 8 bits, which is 2 raised to power 8 minus 1 minus 1, that is 128 minus 1, which is 127. So you will add 127 over here. It will be 124. Now represent it in the form of binary. How you are going to represent it in the form of binary? 8 bits, 0, 64, 32, 96, and then 1. This is for 16, 64, 32, 16. It will be 6 for 10, 12 and 112, and then add 8, 120, and then 4. Then these 2 bits will be 0. Okay, this is the binary representation of 124 in 8 bits. Now your mantissa. What your mantissa is going to store? Your mantissa is going to store the fraction part, which is 0 over here. So all 23 bits will be made 0. So your representation of data will be like this. 1 bit is 0, 0. This is the bias field and it will be having 23 zeros in your mantissa. Now your x is equals to 0.125 can be stored in this format. Let us see how retrieval of this data will be carried out. See, this 0 represents positive data plus sign. This says fractional part is 0. Okay, and this valid bit is always 1. You know this thing. Now see, this is my biased exponent, which is equals to actual exponent plus bias. Now I need to calculate my actual exponent. Actual exponent will be biased exponent minus bias. This is 124 over here. 124 minus 127 is equals to minus 3. Now you have actual exponent, which is 2 raised to the power minus 3. So your data will be 1.000 into 2 raised to the power minus 3, and represented in binary it will be 001, which is 0.125. In this manner your data retrieval will be carried out. So I have told you the representation of your data using 32 bits. You can do same thing using 64 bits. So that's all in floating point arithmetic. Now we will discuss the topics which are important for your computer organization subject. Let us see. So guys, while starting with CO, I divided the whole module into 5 parts. Now see, our first part which we discussed was basic organization. In basic organization, we discussed 5 things. First was memory organization, then input-output organization, then instruction cycle, CPU organization, and instruction execution sequence. We discussed these 5 things over there. But the important things from those topics are instruction cycle. This is very important. And you, if you have followed the video lecture, you can clearly see, if you have missed this basic organization part, it was a difficult thing to get all the remaining concepts, because these were the basics. This instruction cycle defines all the things. Pipelining was involved using instruction cycle, and each and everything requires this instruction cycle. Then was CPU organization. Yes, CPU organization is also an important topic. It is not that important, but it is important, because sometimes you are required to write the number of registers required to calculate a particular expression. For that you should be aware of all these CPU organization. Then instruction execution sequence. This topic is very important. Mark it with the stars. Be focused while studying this particular topic. Then the next topic which we discussed was instruction and addressing modes. Over there, addressing mode is really important. Instruction set is not that important. No direct question is asked. But for solving any question in CO, you should be aware of instruction set. So what can I say? There will be no direct question going to be on instruction set, but its knowledge is required for solving other questions. So it also become important. Sometimes direct questions are asked on addressing modes. So just prepare this very clearly and be thorough with the concept of addressing modes. And more focus is given on transfer of control addressing modes. The next topic which we studied over here is transfer of control and subprogram initialization. Guys, this topic is really important, the most important topic till now, because here we deal with jump, control, such type of instruction. I explained you the concept of halt instruction over there, and question has been asked on halt instruction so many times. So I would suggest be prepared with this topic and try to get the concept. Then the next thing which we studied was instruction pipelining. This is very important. Very important. This whole topic is very important. You are going to get the questions on performance analysis, risk analysis, dependencies and hazards. Each and everything is important over here. You should be aware of all the dependencies problem and the solution which is given to these dependency problem, and be thorough with the formulas which we used over here for calculating my S, which is speed up, for calculating execution time, for pipeline, for non-pipeline system, then for stalls, number of stalls which were created. Be thorough with all these things. Okay, the next topic which we discussed was memory organization, and in memory organization topic, only cache organization I can say, the most important topic is cache organization. You have clearly seen when I discussed these cache organization topic and when I discussed previous year questions, 4 questions I discussed from 2017 paper. You can see the frequency of questions which has been asked from this particular topic. Also, while discussing instruction pipelining, we have seen a lot of questions in recent years. And the concept over here, see, this instruction pipelining is not that easy. It is a bit tricky or bit difficult concept, but it is not something you can't get. So I would suggest you that practice the questions on instruction pipelining after every 5 to 10 days so that you will not forget the concept, and at the time of end, that is when you are going to do your end revision, you need not to put that much effort in this particular topic. So bring this topic into your practice regularly. Same is the concept with cache organization. See, the question which are asked from cache organization are easy and asked from direct concept, but here your accuracy matters a lot, because what answers you are going to get, like 4.72 nanosecond. So many calculations will be needed over here. So for accuracy, practice a good number of questions. Questions will be easy but require accuracy, and accuracy can be brought into your hand or brought into your behavior just by practice. So practice a good number of questions on this thing. Then came the input-output organization. Guys, I would say that this topic is important but not that important. Questions are not asked that frequently from this particular topic. Just get thorough with the hard disk structure and the average time or latency required for accessing this a particular instruction or data read time which you need for accessing the hard disk. And the topic which I discussed, floating point arithmetic, it is not that important, but when you want to score a good rank, it is always good to know each and every topic. So I would suggest you not to miss any topic. Just prioritize things, like study each and everything one time, but now focus on instruction pipelining and this memory organization topic for solving the question. So guys, that's all on CO. I have tried my best to explain you each and every concept which is important for your syllabus while teaching the CO subject. Guys, I have always heard people saying like CO is very difficult subject or it is not easy to score marks in CO. I can say that it is not that easy to score marks in CO, but it is not that tough that you can't score. There is nothing like you cannot score marks in CO. Definitely you can score marks in CO, but the basic things which are required is accuracy and clarity of the concept. There should be no room of confusion for any concept in this particular subject. Then only you can solve the questions on this subject. People will say like it is difficult to score marks in CO, so just leave this subject and devote your time while preparing some other subject. Guys, my suggestion is like listen to everyone, listen the suggestions of everyone, but try this subject one time. You will find it easy and a very conceptual subject. If you find it like you can do it, just go with it. If you find it a bit difficult, don't miss it completely. Try to get those concepts which are important, because if you are going to miss it completely, you are going to lose your 8 to 10 marks, because it has been asked for 8 to 10 marks in the last recent years. We have seen the weightage analysis for this thing. So I would suggest you not to miss it completely if you find it difficult. If any subject seems difficult to you, what is the strategy you can follow? See, fix 2 hours daily for this particular subject only. Try to study concept of this subject daily for around 2 hours. If you can't find 2 hours, fix 1 hour. When you are going to study this subject 1 hour daily, first day it will be difficult, second day, third day, fourth day you will definitely get the concept, and after getting the concept you can solve the questions. So guys, I have tried my best to solve the previous year question on each and every topic. Now it is your time. One more suggestion, when you are referring these videos, I have already mentioned that try to make short notes while studying. Now it is the time you should act. Start acting this particular time. If you are not going to start now, then time will never come. Okay, you have made short notes. If you have not made, just make them again. Now read and revise those short notes. Then try to solve the previous year questions. After solving previous year question, resources are there. You are having so much resources. Try to get the question online, or you can refer some standard book for getting the question. Solve those questions. When you are going to solve the question, definitely you will get a lot of confidence, and confidence is really needed. So solve questions, keep practicing. Next thing, if you are solving questions and you need calculator while performing any calculation, just use Gate Virtual Calculator. For this 1 year, just forget that your mobile is having some calculator. Download Gate Virtual Calculator in your mobile if you are habitual of using calculator in your mobile. If you are using system, use that Gate Virtual Calculator only. This is my suggestion, because people who are not using Gate Virtual Calculator now, they will not be very much familiar with the interface of that calculator, and you are going to waste a good amount of time in calculations in real gate examination. When you have solved questions all the previous years, when you have exhausted all the previous year questions, I would suggest enroll in some test series. Try to give test on this particular subject. Try to solve the questions over there. So guys, that's all. I would suggest that practice is the key for your success. So just practice a lot of questions. And my thinking is, or the way I think is, you should act in such a way that after some time, like do all the things which you can do. Do each and everything which you want to do, and do it just now. So after some time, there will be two cases. Either you are going to get a very good result, then you will be very happy that your all efforts are counted and you get the benefit. But somehow, if result was not that good, okay, then also you will have that satisfaction in your mind that you have done your best. There were not a single mistake which you have committed. You have tried your best for this examination. And if you got this, then okay. Then at least you will have that mental satisfaction. So my suggestion or my way of thinking is, just act completely. Give your 100% to each and everything if you are trying. That's all guys. Again, I wish you all the best for your future and for this examination. Prepare with all the efforts you can put for this examination. Thank you guys.